Okay, I think where we left off was in this spot right here. We had just finished calculating the confidence interval for this pennies problem. We had written our conclusion, and then there was a part B that says, is it plausible that 60% of all of the pennies in the collection are more than 10 years old? Okay, so when you're asked these questions, once you have your interval constructed, you're going to look at the interval, you're going to look at the particular proportion they're asking you if it's plausible or believable that it could be a value for the true proportion of pennies in the collection that are more than 10 years old. And we can see that, yeah, 0.6 is definitely a believable number that could fall in the interval that we've created. And so we would just make a statement, yes, it is plausible that 60% of all the pennies in the collection are more than 10 years old. And our reason is because 0.6 is included in the confidence interval. Okay? Remember, these confidence intervals are basically intervals that we're saying, we're I think this was 99% confident that this interval captures the true proportion of pennies from the collection that are more than 10 years old. So it would be believable that 60% would be a value that would work for this. Okay. Hey, one thing I just wanted to mention that I just didn't necessarily highlight on the 8.1 notes page, and so I thought we'll just do this real quick here, is when we talk about the margin of error, okay, and keep in mind margin of error is really this part right here in the confidence interval, the plus or minus part, okay. That phrase, margin of error, it just really is accounting for any odd variations that might have just happened to have occurred in the sampling process. Okay, doesn't mean that you did any bad sampling. Just we know every once in a while you could do everything right, and it just so happens that the sample that you got was a little bit lopsided. Maybe the values were a little bit higher than what the true parameter is that you're estimating, and that just happens. It's just called sampling variation. That's what the margin of error accounts for. It will never ever account for bad sampling techniques like using non-response or voluntary response or any type of bias. That is not what the margin of error ever is attributed to. Okay. Hey, the next couple pages are really just taken out of the back cover of your textbook. It's a little overwhelming to look at, so it's a list of all the different inference procedures that we're going to be looking at. I have highlighted here on this particular page just kind of the one that we're focusing on right now. We're going to try to make it manageable by, addressing each one kind of thoroughly here, so don't get too overwhelmed by those next two pages. I'm going to have you just take a look at the next example, which is talking about red beads here. Okay, and I noticed, I need to go back and see if I mistyped something, because when we read through this, you're going to notice that it doesn't mention anything about this sample being collected randomly. Of course, we know that's supposed to be one of our conditions that we check. So we're going to assume that that should have been in this problem, and I'll go back and double check and see if I mistyped something or not. Okay, so when we do this four-step process, kind of state, plan, do, conclude, we know one of the things we want to start with is we always want to state the parameter that we're trying to estimate and at what confidence level we're going to do that. So this problem is asking us to calculate and interpret a 90% confidence interval for, and here they're telling you what you're going to estimate, for the proportion of red beads in a container of 3,000 beads. Okay, so we are going to estimate P, which is going to be the true proportion of red beads in a container. Okay, and we're going to do this at a 90% confidence level. Okay. Okay, the plan portion is where there's kind of two parts to this. We always want to name the inference method that we're using, and this particular inference method is based on one sample. We are estimating a proportion. So we call this a one proportion Z interval. Okay, Z because we'll be using a Z critical value to help us construct this confidence interval. Okay, then we're going to go through our 3 steps here for our conditions. Of course, we know the first one is random, and that's where I was saying it really should have been mentioned in this problem that it was random. So we're just going to make this assumption, and we're going to say assume sample was random. Okay, I have read before that the conditions are all supposed to be met for any like free response problems they give you that are similar to this. If for some reason you think it's not, you can state that it's not, but you should continue on with the do step and the conclude step so that you're finishing the entire problem there. Okay, so the next part is the independence piece, which is the 10% condition, and this is where we would show that the rest of the problem goes on to say Mrs. Daniels claims that 50% of the beads are red. We want to use the interval that we're going to construct here to comment on this claim. So we'll do that at the end. The sample proportion you found was 0.426 from a sample of 251 beads. Okay, so we're going to take 10 times 251. Okay, that would be 2,510. And we're going to assume that that's less than or equal to all would be all beads. Oh my goodness, I'm so sorry about how sloppy this is. All beads in container. Gee. All right. Okay. And then the third condition is us checking for normality. Okay, we definitely want that. We're using z-scores that are based on the normal curve. Okay, and this is where we're going to take NP, so N is 251, okay, and the P is the 0.426, okay. We're going to multiply those together. That equals 108.204. That's definitely greater than or equal to 10, okay. And then we're going to do 251 times 1 minus 0.426. Okay, that comes out to 145.796, also greater than or equal to 10. Okay, so we got all those conditions are met. That's great. Okay, so now we're down to the do step. Okay, and the do step is where we're going to go back up to the problem. Remember that 0.426, that's our p hat. That's our sample proportion. Okay, so that's the point estimate. Okay, so for the do step, we're going to start there. We're going to put our plus or minus. After the plus or minus is where we're going to put the z-score. Okay, I'm going to come back and fill that in just a second. Okay, after the z-score, this is where we put the standard error of p hat. Okay, the standard error of p hat. Okay, and that's just nothing more than just the original formula for the standard deviation of p hats. Okay. We put p, and this is going to be 1 minus p, okay, and if we do 1 minus that, we see that 1 minus p is really 0.574, okay, we divide that by n, okay, I'm going to come back and fill in what the z-score is now. Okay, this was a 90% confidence interval. So once again, think through that curve. I want to block off 90% in the middle. That means the tails are each going to contain 10%. Okay, if I'm looking for the z-score that's going to fall right here on the calculator, I'm going to put this underneath here. I'm going to take the extra, divide by 2, so I'm only talking about one tail. Okay, of course we know that's the area, that's the mean, that's the standard deviation. Okay, if we type that in, we get the z-score to be that 1.645. Okay, that's what I'm going to fill in here, 1.645. Okay. All right, so we're going to type into the calculator. Okay, and I like to type in everything to the right of the plus or minus. That kind of shows the margin of error a little bit there. Okay. And then the confidence interval is 0.375 to 0.477. Okay, that's the confidence interval. Right? Okay. Right, and then we're going to go to our conclusion. Okay, conclusion, we're going to say we are 90% confident that the interval, okay, from 0.375 to 0.477 captures the true proportion of red beads. Oh, it's so sloppy. Okay. Now, we were supposed to comment on Mrs. Daniels' claim. Okay. Her claim was that 50% of the beads are red. Okay. So we're going to take a look here and say, well, you know what? Look, if you look at the interval here, 0.5 isn't even in that interval. So we're going to say, because 0.5 is not contained in the interval of plausible values, we should doubt Mrs. Daniels' claim. Okay? Okay, now what I'd like to show you real quick is I'd like to show you how you can do these confidence intervals on your calculator. Now, I say this with a word of caution. When you do this on the calculator portion is only really replacing this do step, okay? And I really encourage you on the homework that unless the problems ask you to use the calculator, to try to use the formula on the homework, because you're going to see that you're going to run into lots of multiple choice questions. They're going to break down the mechanics of the formula, and if you're not comfortable using the formula, you're going to run into problems in some of the multiple choice questions. Okay, so don't do all the homework just with the do step of the calculator. Okay, so what you're going to do is on the calculator, you're going to press the you're going to press the stat key. Okay, that's what you want to press, the black stat key, and you want to bump over to where it says tests. Okay, now there are all kinds of tests here, and you want to be really careful. You want to scroll down and make sure that you pick the test. This is why I've been calling it this. You want to pick the test that's called one proportional z interval. I think it's actually like letter A, at least it is on my calculator. Okay, when you select that, it's going to ask you for three things. It's going to ask you for x, it's going to ask you for n, and it's going to ask you for a confidence level. Okay, the n is what we always know to be, and that is the sample size. Okay, so on this problem, the sample size was 251. Okay, so I'm just going to write that down here on the paper. Okay, the confidence level is obviously, what were we doing here? 90%. Okay, so you do 0.90. And then the x is, of those 251 that were in the sample, how many of them were red beads? Okay, now here's where you got to watch. They didn't actually tell us that in the problem. They told us in the problem that 42.6% of them were red beads. Okay, so what we're going to have to do is we're going to have to figure out, okay, 0.426 of 251 is 106.926. Okay, now you can't type a decimal in here, so you're going to round that up to 107, and these are going to be your three entries that you're going to enter in. Okay, and when you do that, and you can go ahead and do that on your calculator and press enter, it should spit out, and this isn't the right one right here, but it should spit out the same confidence interval that you got up here when you did the formula.